Okay, thank you. Okay, so the talk in the channels A and B is gonna be a very it's a talk that I'm very fond of because if you've been following me, I've been all over cryptocurrencies lately. So this is an interesting one. I thank Bernardo and Victor very much because they were notified like in the last minute, so they had to rush with their talk. They just flew from Rio de Janeiro to make it to the event. So I thank them very much. And here on channel C and D, we're gonna see Mr. Lucas Fernandes talking about JavaScript fatigue. This is another topic that I'm very fond of. Fatigue about talking about JavaScript as well. But anyways, I hope you enjoy. Channels A and B, I give you Bernardo and Victor, and channel C and D, I give you Lucas. So let's get rolling.
Okay, so hello everyone. My name is Lucas, and today I'm here to talk to you a bit about JavaScript fatigue. So who here knows what JavaScript fatigue is? Please raise your hands. Okay, great. The ones that didn't raise their hands, I'm sure they listened to the other talk because, well, if you do JavaScript, you know what JavaScript fatigue is, or the other reason is maybe you don't know JavaScript. So this talk is going to be very polemic. I wrote a blog post about it 2 months ago, I think. I was at Nebraska JS and I talked about this. And lots of people came to me and asked about my opinion on this topic, about other considerations, other aspects of this. And well, it's very hard to talk about JavaScript fatigue without stepping on anybody's toes. So I got really offended with some of the comments. There were very nasty things, very mean things people said to me. And well, especially this one, it hurt me a lot, which is, I bet the author uses spaces instead of tabs. Well, I plead guilty to that. I do use spaces. Sorry. Okay, so, well, as I've said, my name is Lucas. Up there is my Twitter handle, my GitHub handle. If you want to talk to me there, feel free to do so. I'm a maintainer of both Chai.js and Signer.js. If you have ever used that, please raise your hands. If you like it, please raise your hands. Okay, the ones that didn't again are listening to their talk. And well, I also organize Flipper.js in my city, and I'm always writing in my blog. It's everything in English, but you can go there if you want to read more. So let's keep going. This talk, well, this talk's not hardcore. There are going to be no data structures. There's going to be no fancy algorithms. And there's going to be no math. I apologize for that. If you want to read about that, you go to my blog. But this talk is about making decisions. This talk is about how we can learn with JavaScript fatigue and take more effective decisions and be less overwhelmed with JavaScript fatigue. Because, well, JavaScript fatigue is just the feeling you get when you are overwhelmed by the amount of things you got to study, right? Because we got so many frameworks, so many tools. The ecosystem in JavaScript is so vibrant, sometimes people get overwhelmed. And well, the first thing I'd like to talk about something people don't usually teach in college. And please don't get me wrong, I think college is great, I think college is awesome. But it just lacks a very important subject, which is realities of the industry 101, right? And the first truth out here is that software solves business problems. This is a great advice from a blog post called Don't Call Yourself a Programmer and Other Career Advice, which I highly recommend you to read. And well, basically, software does not exist to please you. As we've seen in the first talk today, software does not exist to make us programmers happy. And the second truth here is that you're not paid to write code. You're paid to create value, you're paid to solve problems, right? And actually, the less code you write, the better. Unfortunately, you're probably in the business of unemploying people. And that's why basic income is going to get a lot more important in the next few years. So actually, if you could have a machine that does your job, well, that would be a lot better for your company, right? So keep in mind that technology is not a goal. Writing bug-free software is not a goal. Writing beautiful code is not a goal. Using hipster frameworks and hipster programming languages to be the cool kid on the block is not a goal. The only thing that matters is cost versus revenue. So the more you decrease your costs and the more you increase your revenue, the better professional you are, right? So we don't write bug-free code because we as programmers like correctness. We write bug-free code because our clients don't like bugs. And if you have ever had a bug becoming a feature, you know what I'm talking about, right? Because, well, if a bug becomes a feature, then, well, your client likes it. It increases your revenue. So why would you fix it? We don't fix bugs because of correctness, right? We don't write beautiful code because we like beautiful code. We write beautiful code because it makes us more productive in the long run. And being more productive in the long run decreases costs and increases revenue, and usually decreases the amount of bugs, which, you know, most of the times are bad. And all those things, you know, rockets, self-driving cars, robots, AI, all that stuff, I'm sure Elon Musk thinks it's pretty cool. I do think it's pretty cool, but people are doing that because they have economic interests, right? They want profit. That's why these things exist. So maybe I should not even call this section Realities of University 101. Maybe I should just call it Realities of Capitalism 101. So maybe we should start paying more attention to other things other than coding, right? We should be paying more attention to soft skills, to design. In this study, in 1975, Bowen has showed that at least in the software he studied, only 36% of errors came from coding, and 64% came from design. In the NASA Apollo project, about 73% of all errors were design errors. And this is not just any study, it was studied by Margaret Hamilton. And, well, without good design, it is hard for good code to exist. And without design, it is impossible for any code to exist at all. Code must accomplish a goal, right? Without the requirements or design, programming is the art of adding bugs to an empty text file. And you know, these things, all the tools we have in JavaScript, Browserify, NPM, React, TypeScript, Babel, Mocha, all that stuff, it exists to solve a problem, right? If we don't understand which problem these technologies are solving, we're not going to make the right decision. This is something I wrote on Twitter once, and I think it's pretty much true, is that JavaScript fatigue happens when people use tools they don't need to solve problems they don't have. And as Donald Knuth says, premature optimization is the root of all evil. You know, why would we add unnecessary complexity in our software if we don't need it, if we're not sure we're going to need it? Right? I'm going to talk a lot about this later, but keep that in mind. And well, if you think too much about performance, I have a great quote for you. So the greatest performance improvement of all is when a system goes from not working to working. And let's get going with some more quotes. This one is by Rob Pike. He says that fancy algorithms are slow when n is small, and n is usually small. Well, I'm happy for you if you work in a big company with lots of data, lots of users, and all those things, you know. I'm very, very happy for you because you got big problems to solve. You got to think about these things. But, you know, if you don't, well, usually you're just going to waste your time with fancy stuff you are not sure you're going to need. And, well, there's a great quote by Program in which he says, build things that don't scale. And I'm going to talk more about that later. So I'm sure most of you have heard of test-driven development. And you know, here I'm not just going to advocate for it because, well, most people know they should write tests and then write code. And, well, that's pretty much commonplace. What I'm going to say is that you should adopt a TDD approach for every problem you want to solve, right? So let me explain this to you. Basically, what I mean is that you should wait for problems to appear before you can solve them. And, well, TDD is pretty much about that. You create a problem, and then you solve it. And by doing this, you also reduce the scope of the decisions you need to make, and you reduce the number of choices. which therefore decreases analysis paralysis. And analysis paralysis is basically what happens when you open Netflix and you got 1,000 options and you end up spending 2 hours and choosing nothing, right? This is analysis paralysis. And this is bad because more choices mean less satisfaction. So the more choices you have, less satisfaction you get from it. You know, there are studies that prove it. In his great book, The Paradox of Choice, Ben Schwartz says that as the number of options increase, the costs in time and effort of gathering information needed to make a good choice also increase. So the more choices you have, the more options you get available, the more you get research, the more attached emotionally you get to the choice. And as our great Brazilian poet from Charlie Brown Jr. says, each choice means renounce, right? And so, have you ever wondered why surprise box subscriptions are so popular nowadays? Well, that's basically because they're taking choice away from you, so you gotta get satisfaction from that box, right? And that's because our willpower is limited. You know, that's why these people wear the same clothes to work every day. And there's a great documentary about it on Netflix right now. It's called Minimalism. Well, I think there's a few problems with it because it's just like some rich white guys telling other people how to behave, and that's not very cool. But anyway, your willpower is limited, and it works just like a muscle. So the more you use it, the more tired it gets. This is a great study by the National Academy of Sciences, which compares the number of favorable decisions judges make with the time of the trial. So basically, in the y-axis, we have the percentage of favorable decisions, and in the x-axis, we have time, right? So as the day starts, as you can see up there, judges are more prone to making favorable decisions. Like there's like 65% of chances judges will make a favorable decisions in the start of the day. As the time approaches, like lunchtime, that decreases to zero steadily. And after lunch, when judges came back, well, their rate of favorable decisions goes up again to 65%. Again, it drops, and after another break, it goes up to almost 65% again, and drops steadily to 0, right? Which means we make poor choices when we're tired. So if we try to do many choices, you know, one after the other, we'll get tired, we'll make bad decisions. So we should do one decision at a time. We should wait for problems to arrive before we can solve it. And maybe we might not even just be like JavaScript fatigue. I think we're just decision fatigue, right? So let's talk a bit about JavaScript, about our environment, how we came to this. Basically, I think there's no better way of telling how real this is without showing people a bunch of impressive numbers. Like from 2015 to 2017, we almost like doubled any other package repositories of other languages. By the time I was updating these slides, we had 520,000 packages on NPM. That's an average of 494 packages a day. The birth rate in my city, in Florianopolis, is 400 babies a month, which means we will need to have almost 30 times more kids if you want every one of them to test an NPM package. So the NPM registry traffic has grown 1,000 times. Yeah, 1,000 times in the last 5 years. And that's like 100,000% growth since 2012. But how did that happen? How did we come to this place? Well, that has a lot to do with the history of JavaScript. Well, it all starts in '92 when a company called Numbers created a language called C++. And you know, as the popularity of Netscape grew, they created a technology called Espresso Pages, which allowed them to embed this into web pages. But then they renamed CMM to Script Ease because, you know, people think C is hard. Yeah, that's the reason they renamed it. And then in '95, JavaScript was created in 10 days, as you can tell by its syntax. So It aimed to handle input, validation, and decline to save round trips to the server. And at that time, they used Perl on the server, and it was kind of hard. It was kind of bad for having these multiple round trips. So since then, JavaScript became a must-have. And in 1995, Microsoft releases Internet Explorer with JavaScript clone, basically. And now we have 2 different languages in this whole web environment. Script is JavaScript, JScript. So it's obvious we need a standard. And in 1997, a proposal was submitted to the ECMA committee, and the TC39, the Technical Committee 39, was assigned to the standardization of a general-purpose, cross-platform, vendor-neutral programming language they call ECMAScript for diplomatic purposes. And basically, ECMAScript became the basis, it is the spec for all JavaScript implementations. So JavaScript is an implementation of ECMAScript, basically. And since then, we had many ECMAScript versions. We had ES1 in 97, ES2 in 98, ES3 in 99, and we had a few problems with ES4. So we had a lot of trouble here, and we ended up having ES5 in 2009. So as you can see here, it took us a long time to get from ES3 to ES5. And that's a problem because the standard didn't move fast enough. We needed new features. And then ES6 came, and there's a lot of things going. We have different features. We have different browsers in the market. So each browser implements has different levels of support for these things. And most of them have a relevant portion of the market. So transpilers don't exist just because we think it's cool to write bleeding edge code. Transpilers exist because of all this trouble with different levels of supporting browsers, with all the troubles we've had with the standards. And it also allows us to, test new specs before they come out and, maybe submit proper feedback or anything like that. It even allows us to try new things. This pretty much flopped, but let's not talk about that. And so module bundlers also solve a very important problem we always had in JavaScript. So if you do JavaScript for a long time, you probably remember when you had to organize your script tags in order of dependency and deal with multiple versions of jQuery and all that stuff. So basically, module bundlers exist to solve that. Front-end frameworks. We have many of them, and I think we should not complain about them because they provide us different abstractions to deal with different problems, and we have power of choice, right? And basically, abstractions, they're necessary to reduce the cognitive load of how things work so that you can focus on creating. So you can stop worrying about manipulating the DOM all the time and doing low-level things. You add an abstraction, and on top of that, you can focus on what matters. Of course, it has a cost. You're adding directions, and things are not concrete. But as Kinbeck says, first you learn the value of abstraction, then you learn the cost of abstraction, and then you're ready to engineer. And all that stuff happens because the web platform moves too fast. Standards probably don't, right? And well, as Mike Rogers from Node Foundation says, standardization most of the time kills innovation. So we got to move fast because we got the mobile revolution, we got mobile networks going on, and web platform moves fast. So we need technology that can move fast too, and technology that can move fast means open source technology, means technology people can opinionate on and build fast. And of course, more tools mean more choices, and this might take us to analysis paralysis and all that stuff. But it also favors natural selection. Because modules that thrive, that people use, we end up getting more contributors, more feedback, they'll move faster, and they'll grow. While the ones that don't will probably be deprecated, we'll have less people maintaining them. And well, that's just how things happen. So this favors natural selection. And well, it's good that we have many choices because good programmers know what to write. But great ones know what to rewrite and reuse. And this has a lot to do with the Unix philosophy, in which you do things that do one thing and you do it well. So in Java, we had like JUnit, which runs tests, has assertions, and all that kind of stuff. But in JavaScript, we have very separate concerns. So Shy.js just does assertions, while Mocha just runs tests, and that's it. So if you need to switch one of these pieces, you can just go on there and switch it, and everything will be okay. And the Unix philosophy also says that you should write programs that work together. So if you want to run your tests in multiple browsers or anything like that, you can just add Karma to this and things will work. And it's also important to keep in mind that our tools, they're not new. NPM, for example, well, before that we had RubyGems, we had Maven Central, all that stuff. So NPM is not a new idea. JSX, mixing HTML and JavaScript, that's not a new idea. It existed 13 years ago, and it was called E4X. Babel, it just applies the same principles any compiler applies to your code, the same principles GCC uses, right? So it's all compiler theory. And, well, compilers, the guy that came up with the whole theory and most of the theoretical basis for it, he's not even a programmer. He's a linguist, right? His name is Noam Chomsky. And gulp, NPM scripts, grunt, all that stuff, we had that in '76, and we called it GNU Make. So there are even many projects that still use GNU Make. We use GNU Make in Shy, not because we're super hipsters, but because it solves our problem. It's simple enough for us. That's why I use it. Using web technology for mobile, well, we already done that. We called it Symbian WRT. But, well, I talked a lot about JavaScript fatigue. How do we deal with it? The first thing to keep in mind is that you don't need to know everything, right? So you can wait for problems to appear before you solve them. You can learn things on demand, and you can focus on what interests you. Because science has already proved that you're going to be more effective at what you find interesting, at what you like. So learn what you like, learn what interests you, not only in tech, but in any other area. And as problems arrive, you will be able to learn and solve them. And please, do not be defined by your stack, right? So don't define yourself as a JavaScript programmer, as a Ruby programmer. You're a professional that solves problems, right? That's what you do. You create value. You either decrease costs or you increase revenue. That's what you do. So let's say Douglas Crockford or any other great programmer. But let's talk about Douglas Crockford, for example. So let's say he does not know Go, right? I'm not sure he does not know Go. Well, he knows everything, but let's suppose he does not know Go. If he walks into a Go shop and he says, well, I want a job, they're going to give him a job. That's not even a question because he's good at solving problems, he's a good engineer, he's good at what he does. It doesn't matter which language he uses. So I really love this. I get really happy when I get to tell people this story. So this one is called Master Fu and the Recruiter. It gives me chills. So a technical recruiter, having discovered that the ways of Unix hackers were strange to him, sought an audience with Master Fu to learn more about the way. The recruiter said, I have observed that Unix hackers call or become annoyed when I ask them how many years of experience they have in a new programming language. Why is this so? Master Fu stood and began to pace across the office floor. The recruiter was puzzled and asked, what are you doing? I'm learning to walk, replied Master Fu. I saw you walk through that door, the recruiter exclaimed. And you're not stumbling over your feet. Obviously, you already know how to walk. Yes, but this floor is new to me. Oh. Upon hearing this, the recruiter was delighted. Right, so this pretty much sums it up. And well, when you're going to learn something, start from the beginning, learn computer science fundamentals, learn JavaScript, learn CSS, HTML, learn about the HTTP protocol, no fundamental concepts, right? But don't be afraid to try new things too. Because, if you're trying to learn React and you just spend too much time learning JavaScript, you're just basically trying to learn how to swim by studying dynamic of fluids, right? So don't be too attached to a single technology, and don't even be too attached to technology too. As I have already mentioned, the guy that invented most of the theory we use in compilers nowadays, he was a linguist, right? We can learn many things from other areas, and we should not be attached to a single technology. Another great advice a colleague has given me once is to dig deep. So when you're interested about something, when you want to really learn how something works, dig deep, Don't be satisfied just by learning how to use something. Learn how it works so that it does not seem like magic anymore. There's a great quote by Richard Feynman I really like, which is, "What I cannot create, I do not understand." And in the same blackboard in which he wrote this phrase, just below he wrote, "Know how to solve every problem that has been solved." And when he wrote that, he was certainly not talking about software engineering. He was talking about being able to get any theoretical result and rederive it to the point he wanted. But basically, I think the same principles apply here. So we should learn how to solve problems that have already been solved. When you're reading, you just need to read and you learn. If you didn't understand, you just go there and read again. The difficult thing was for someone to come up with that idea and put it into a book, right? The knowledge is already there. So when you're trying to learn something and sometimes you do not understand, go see the source code, go see how people created that. There are great videos by Dan Abramov in which he explains how Redux work. There are great posts about how JSX interpreters work, all that kind of stuff. So try to build things on your own. Of course, you probably won't get all the implementation details right in the first time, because there's a lot of knowledge involved in every code base. But just try it, just for the sake of knowledge. And focus on what matters, Probably many of you have heard of the Parkinson's law of triviality, which says that members of an organization give disproportionate weights to trivial issues, right? That's also called backshedding. Basically, the example he uses is that when people are building a nuclear power plant, they will spend like 80% of their time deciding the color and the appearance of the backshed instead of actually working on the power plant. And this happens because a power plant is so complicated, people just assume everybody working on it has enough knowledge. They know enough to make it. While a backshed, well, that's a simple thing. Anyone can opinionate on it. It's just like spaces versus tabs. That's why we never came to a conclusion. And the whole point of this talk, what I've been talking till now, is that you should not get ahead of yourself. Have a TDD approach for everything you do. Wait for problems to appear before you solve them, right? And as I've mentioned before, do things that don't scale. This is a title from a blog post by this guy, Pro Graham. He is one of the guys from Y Combinator, so he's very rich and he knows lots of things, so we probably should listen to him. And in this blog post, he explains how the people at our Airbnb built their whole platform, their whole service in a non-scalable way, and they grew it over time, right? So they went to people's houses and they explained how it worked, and they did things by themselves and all that kind of stuff. So do things that don't scale as needed. There's also a great blog post by Elon Musk. Yeah, I really like this guy. In which he tells us what his master plan with Tesla is. And the first point in it is to create a low volume car, which would be expensive, right? So a few units, very expensive. Then develop a medium volume car at a lower price. Then use that money to create an affordable high volume car. And he's also going to provide solar power, but that does not come into the equation. So this right here is the Tesla Roadster, and the other car right there is the Tesla Model 3. So the Tesla Roadster costs about $110,000, while the Tesla Model 3, which is the latest Tesla available, costs about $35,000. The Tesla Roadster sold only 2,400 units. Tesla Model 3 has sold, well, it's not being released yet, but it had 200,000 units reserved on its first day before release. Okay, but what about solar power? Well, that's not coming to the equation, but Elon Musk owns the biggest factory in the world. So I guess that's not going to be a problem. So basically it means that software should not be built like this. It should be built in an incremental way, like this. Okay, but that's cliche. So let me tell you about something I read in another very cool essay. I think it's by Eric S. Raymond too. It's called The Cathedral and the Bazaar, in which he compares the way we build software with the way we build cathedrals and we build bazaar. So cathedrals are basically enterprise software, big software that moves slow in general. It's centralized, it's carefully crafted by individual wizards with no beta or release before its time. Well, the bazaar, in the bazaar they release early and often. They delegate everything. They communicate, and they listen to feedback. That's basically how Linux works, that's basically how open source works. And this can be pretty much compared to two very different development philosophies, which are the right thing and worse is better. So the right thing focuses on correctness and this kind of stuff, and worse is better focuses on simplicity. So in the right thing, it's more important for the interface to be more simple than the implementation. While simplicity concern in worse is better is that simplicity is the most important consideration in design. The right thing says that incorrectness is simply not allowed, while worse is better says it is slightly better to be simple than correct. The right thing also says the design must be consistent when it comes to consistency, while worse is better says that the design must not be overly consistent. Because we gotta favor simplicity, right? And finally, when it comes to completeness, the right thing says that simplicity is not allowed to overly reduce completeness. While in worse is better, completeness can be sacrificed in favor of any other quality. But there's a small problem here, just a very small problem, is that this thing might take forever to build. That happens, right? But this is a problem. This is the problem in the way we build software most of the times. So React, for example, they focus on solving a single problem. They focus on being simple. And if people need any other things, such as global state, well, then other people can come in and develop their own solution for that. That's why you have Redux. That's why you have many technologies that have been built to work with React. So maybe we should start being more like a bazaar instead of a cathedral. And maybe we should start adopting worse is better more than we adopt the right thing. And also something I'd like to tell you about is our role, because that is very related to the way we develop software. So should we call ourselves really engineers? Well, I'm not sure we're engineers. That might even sound a bit arrogant sometimes because, it's great to call yourself an engineer, that status. But I don't think that's exactly what we do. So engineering has been around for, many years. The Colosseum is still up, while your iPhone crashes every day. And we've been writing programs for what we know as computers for like 70 years or something like that. And I have a very simple example to demonstrate this. So this right here is Barcelona, great city, awesome place to be. And when you look at it like from this distance, like this, it's just like a common city. But when you look at Barcelona from above, well, every single block has been planned, right? And, well, the people that built Barcelona at that time could not predict what it was going to look like. They didn't know what Barcelona is going to look like, how people were going to move from one place to another. they had to figure out as the time goes by. They had to let it grow organically, right? So maybe we should be more like the people that built Barcelona. Maybe we should be town planners instead of being engineers, you know? Software, of course, is flexible. Engineering is not. Our build time is compile time. We spend more time designing and thinking than building. We can break things. We can always change things. We can build as many times as we want. So software is very flexible. Basically, I think we should act more as town planners. We should let our software grow and adapt as needed. You know, solve one problem at a time. And, well, solving one problem at a time means adopting the right abstractions when they're needed. And abstractions only work well in the right context, and the right context develops as the system develops. Another great advice a friend from college has given me once was that I should strive to be lazy, right? So if you're a programmer, you know what I'm talking about. You like to automate stuff. You don't like to do repetitive and boring tasks. So you should strive to be lazy. You know, if you're doing something over and over again, maybe there's a better way to do it. Maybe someone has already solved that problem. So strive to be lazy. Always look for better ways to solve problems. That's why we have most of the tools we have in JavaScript, because there are better ways of solving problems. And well, make sure you talk to people. We're in an awesome conference right now. Look at how many people are here around you. So we often like to think that we as, you know, software people can solve any problem by Googling or going to Stack Overflow, but the reality is that sometimes you won't even see there's a problem. So when you talk to people, you end up learning how they solve their problems, and you might even find problems that you didn't even know existed. How many times have you ever like Googled for an error or for something, but you know, you couldn't find the answer? Well, that's maybe because you're searching for the answer for the wrong question. So when you talk to people, you discover new problems, you discover real problems. And be curious, read widely, try new things. What people call intelligence just boils down to curiosity, right? So when you like what you do, you're going to go deeper, you're going to really like it, you're going to be more productive. So be curious. But if I had to give you only one advice during this whole talk, if I was only allowed to give you a single advice, it would be to solve problems. You know, that's why you're here. You're here to solve problems. That's pretty much it. I'd like to thank you very much. If you want to talk to me, you can find me on Twitter or GitHub. And there's my email in my website too. So here I've got lots of material. If you want to read on it later, I'll make sure these slides are available online. Thank you very much. Okay, so I think I got 8 minutes. So I'll just go on to Twitter and see if there are any doubts here. Okay, here we go. So I should do a search for hashtag QA, Lucas, Fernandes, Costa. Okay, there we go. Let's see if we have anything. Well, I don't think we do. Do we? No, we don't. Okay, I think that's it. Thank you again.